Hey everyone, how's it going? Today for our tech drop-in, my name is Chris Gunn. I'm one of the solutions architects with Megaport, and I wanted to go through some material we put together around just cloud on-ramps, a little bit more of an advanced dive into it, get into some deeper concepts, and then get around some best practices about building your own cloud on-ramp. So this won't be a 101 introduction to what is ExpressRoute, what is Direct Connect. This is going to be more some generalized concepts that you see with with most providers that are offering cloud on-ramps. And usually, how do we kind of design around it? What are some things we need to consider? What are some options? And then get into some cases like, all right, difference between dedicated versus provider hosted. What does that mean for first, middle, and last mile connectivity going into those cloud providers? What about geography and regions? Do I need to necessarily get an on-ramp that is tied to the region inside my cloud provider I'm trying to reach to? And then also different ways in which peering is kind of conducted at layer three. Am I trying to reach private resourcing? Am I trying to connect to the public peering VIF option? So we're going to kind of try and get into this, hopefully demystify a little bit of this. And I'm going to try and keep this as generalized as possible because in this realm, when we're talking about cloud connectivity, it starts getting very vendor specific very quickly, depending upon what we're trying to do and how we're trying to build this connectivity. However, there's still, like I said, some topics that are still pretty universal, and we're going to try and stay in that realm. But if we need to get specific, we're probably going to keep it in the AWS Azure realm of things to kind of break it down on a one-by-one basis. And there will be one or two specific use cases we might talk about, like AWS local zones when it comes to geography, since that's a whole other can of worms to kind of get into. So let's get started. So first, let's just get into, right, what do we need to think about from like a layer one perspective when we're trying to build this cloud on-ramp, all right? Well, we need to be thinking about it in terms of, kind of like any other logistics system. I mean, that's kind of the perspective on it, is just that how do we build that first, middle, and last mile? And first, let's just kind of define what all of that is at the end of the day. So first mile is we have our cloud provider. Let's say just in this case, AWS, right? They're located inside. They have on-ramp points deployed inside specific data centers and colo facilities. So how we actually get connectivity inside that colo facility into, right, that cloud provider's equipment, that would be the first mile. That's the first jump from the cloud provider going towards you, the customer, at the end of the day. All right. Then after that, normally that connectivity would then connect to the provider network. And then that provider network, right, could be, any kind of network service provider, any WAN offering, or in this case, Megaport, right, as far as offering connectivity, from that colo facility to get it as close as we possibly can to your front doorstep. All right. So if we were thinking about this from like UPS standpoint, right? The middle mile would be effectively, first mile would be effectively the warehouse or shipper or whoever you're buying the product from, dropping the product off to UPS. All right. And then the middle mile is essentially them picking it up, putting it on a plane, flying it over to your regional facility, and then dropping it off for delivery. All right. And then that last mile is effectively them taking that package and then delivering it to your doorstep. So in terms of networking, right, that last mile would effectively be, all right, now that we've kind of gotten to your general region as far as where you're located, it's getting that physical connectivity from your equipment into where you are. So now if you're already inside the colo facility, last mile is essentially already taken care of, at least if you're on with Megaport, because we can then build that connection via cross connect. So I guess the last mile would essentially be that cross connect inside the colo. Or if you have like a local loop or, service providers running a point-to-point connection from your on-prem data center to the colo facility, right? That would also be the last mile. But last mile could also be internet at the end of the day. It could be doing internet connectivity to via IPsec to some equipment that you might have present inside the middle mile. And then from there, we can route it up from our provider network going to the middle mile to the rest of these cloud providers, right? So it's important to break that down because when we start talking about hosted and dedicated or provider hosted and then dedicated cloud connectivity, it starts to kind of change some of these concepts and what the requirements are and what the onus is on you as the customer. First being with dedicated. So dedicated is if essentially you are building your own last mile effectively to the provider equipment. It's going to be your connection going from your port, and it could be through a provider network. You could physically have equipment inside that same data center. Doesn't matter, but it's going to be your dedicated layer one connection into your CSP's equipment. All right. So that's kind of at the root of what dedicated is. And some key things to that is one, you got to own that last mile, which means you're going to be paying the cross connect fees inside the colo. You're going to have to own that connectivity. But the advantages are, at the end of the day, is this gives you an option to do potentially higher bandwidth than provider hosted. With dedicated, you can go up to 100 gigs versus, provider hosted options don't necessarily touch on that amount of bandwidth. And then also you get an option for MACsec encryption. And the reason why you can do MACsec encryption with dedicated, but not provider hosted, is MACsec tends to encrypt the VLAN header inside the traffic. And normally, at least in Megaport side, as far as how we're differentiating traffic going into the cloud providers, is via VLAN tagging individual customers as far as who's using our on-ramps in with the providers. If that's all getting encrypted via MACsec, because one customer is trying to encrypt that traffic, right, that kind of breaks that whole model of segmenting out that traffic. So that's why MACsec really only works if you're trying to do a direct or dedicated method as far as connecting to these cloud on-ramps. But with provider hosted is we already built that layer one last mile effectively. We've essentially purchased, 100 gig connections, these different cloud providers. And what we're doing in this case is we are just slicing off a piece of that bandwidth and then giving it to you, the customers, and then segmenting it right via those layer two VLAN tags at the end of the day. So what this means is you can potentially get that cloud connectivity for significantly less than maybe what's being offered by the provider, and also cheaper because you don't necessarily need to own that last mile cross connect. We are already taking care of it effectively. And bandwidth wise, it really depends upon provider as far as what your maximums are here. Like Azure today goes up to 10. AWS for hosted connections goes up to 25. GCP, it depends on where you're landing at, but you can go to 10, 25, or 50, depending upon which colo facility we're talking about at the end of the day. So it varies a little bit from provider to provider basis, but you still get a fair amount of bandwidth. It's just if you needed 100 gigs for whatever reason, dedicated would definitely have to be the path you would go. So kind of the benefits with, trying to do that provider hosted method. So I only really recommend, that the dedicated if the customer absolutely needs MACsec or absolutely needs 100 gigs at the end of the day. But with that kind of understood, as far as how the layer one peering is generally set up and how we're kind of building that layer two connectivity, let's just talk a little bit about geography and actually what on-ramps we kind of need to select. Because as you start looking at cloud providers, every cloud provider's on-ramp normally has a region associated with it. And this starts to build a lot of confusion, right? Because let's say you're located in this example, San Jose, and you're trying to connect to your AWS region in US East 2, okay? Now, you could think that, oh man, do I need to use this on-ramp that is specifically in US East 2? And what are the benefits of me going just direct to the on-ramp versus if I could maybe potentially do an on-ramp that's in a completely different region, but is perhaps close to me? There's pros and cons with both of these options. So for one thing, on the AWS side, when you use an on-ramp, you can typically, and this is kind of generally across all the CSPs, you can usually for free connect to any other region that's within your same geopolitical region. So in this case, if we were talking about the continental United States, and I was connecting to US West 2, I can normally peer via direct connect or express route directly to US East 2 and not be incurred an additional fee or charge for that. This starts getting a little bit different when we start talking about, trying to do global peerings. Like if I, let's say, was coming in from San Jose on my Azure via Azure Express route, and then I wanted to peer with a region in Australia, all right, I would need actually a premium SKU to pull that off. The standard SKU, which is, the lowest tier as far as building that express route, wouldn't cut it. I would need that premium SKU to actually build that connectivity at the end of the day, which comes at a different cost. But the alternative is driving the rest of your way, getting your traffic to the closest available on-ramp, which the added benefits there at the end of the day is if you trust the middle mile provider's network to, give you, how can I say, similar or better latency, or if you like some of the monitoring tools or features, or you just want more control as far as how your traffic is routing, going to that general region instead of necessarily going through the provider's backbone network. That might be a reason you might go with a provider like Megaport to actually get you to the front doorstep of the region rather than dropping at the closest on-ramp. But the downside is sometimes this comes with additional cost because, right, when it comes to driving traffic normally it's going to be charged in or at least from our standpoint, it's going to be charged via either how much bandwidth you're using or distance you're covering via regions. So if you're going from west region to east region versus staying inside metro, there might be a difference in cost associated with it. So it all kind of depends as far as what your objectives are. Normally by default, as it's just a quick and dirty, I would typically recommend use your closest available on-ramp, but there's a lot of other factors that kind of come into play. What are your requirements? Are you trying to do kind of HA? If you're trying to diversify, are you trying to diversify different metros for how you're actually building this connectivity via your on-ramps? So it all kind of depends as far as what you're trying to accomplish. But the key thing is that you don't necessarily need to get an on-ramp in the region you're trying to connect to. You can use your closest available on-ramp, and as long as you're within the same geopolitical region as where you're trying to reach, you should be fine. Now, that being said, it gets a little bit confusing when we start talking about AWS local zones. Because, for those of you that don't know, AWS local zones is essentially, think about it as parent-child zones. It's a child zone that is tied to a much larger regional zone, but it has some local compute. So that way, take, for example, someone was inside Chicago and they wanted some very fast local compute to the metro area. The problem is that the Chicago region, its parent region is North Virginia inside a data center there. So which means all that traffic would have to route back to North Virginia and then route back to Chicago if it was using the compute inside of its parent region. And that's where the value is of the local zone. If you need some really super low latency connectivity or for compute, they could stand up this instance inside that Chicago local zone, and then it can hit that and then route back. And so it's not necessarily hairpinning back to a data center in North Virginia. However, it gets a little bit confusing because, and actually I'd take it back. Sorry. The local zone is associated with North Virginia. The actual AWS region associated with US or for on-ramps inside Chicago are associated with Ohio. And that's where a lot of the confusion comes into play. Clearly, I confuse myself sometimes with some of this. It's because the on-ramps inside Chicago, like I said, are associated with Ohio, but Chicago as a child region, as a local zone, is associated with North Virginia. So this creates some confusion as far as, well, shoot, do I need to to connect to this local zone? Do I need to connect this to an on-ramp in North Virginia? Do I need to connect this to an on-ramp inside Chicago? What gets me the best performance at the end of the day? And how AWS kind of treats it from an on-ramp standpoint is as soon as you jump into any of their on-ramps, you just peer with whatever you're trying to reach inside that geopolitical region. And then so that is going to be the most efficient path. So in this case, if you are trying to build direct connect inside the local zone in Chicago and you want to peer directly with your resources there inside the local zone, the recommendation is use a Chicago on-ramp. Use your closest available on-ramp to reduce latency. And so that way you get the closest path going to your local zone. Because otherwise, if you're peering with the parent zone for that local zone, North Virginia, you're just hairpinning your traffic back again. And then same thing if we were to peer with, Ohio, it's similar scenario. So Just use your closest available on-ramp. All right, next thing, now that we've kind of like established, layer one, layer two connectivity, let's just talk a little bit as far as, public and private connectivity. Because as soon as you connect on, right, it gives you a couple of options as far as what you can actually reach out to. And so private connectivity is by far, the most common use case. This is for your IaaS deployments that you're deploying inside private IP addressing. And so if you're spinning up like, an EC2 instance and you're trying to get access to it and something like that, right? You're going to be doing it via a private VIF or a private peering option to actually go in. Now, this is going to differentiate from the public peering option, or, in Microsoft Azure, the Microsoft peering option, which gets you into, right, those public SaaS applications like Office 365, Salesforce, what have you, right? But similar thing with public peering. This is, the intent here is 100% if you're trying to advertise some of your public addressing space to be accessible into the CSP, or you are trying to access a SaaS application that's available inside the public peering option. That's typically how public peering is used. It is less common, but it does require some public IP addressing space to be used. It does not use the private RFC 1918 IP addressing space. So keep that in mind. If you are trying to peer with public resources that way, you do need some public IP addressing in order to be able to get this going. But those are typically kind of the two routes you would go as far as, all right, now that I've connected, what do I need to do kind of from a layer 3 standpoint? And the first question you got to ask is, what are you trying to reach? What are you trying to get out to? But from here on, we're just going to keep it focused on that private peering option if you're trying to reach your IaaS services, because public peering, right, gets very use case specific as far as what you're trying to reach. But from there, gateways really become the key as far as what you're trying to reach. And once again, this is where it starts getting extremely vendor specific as far as who we're talking about. But gateways almost in an effect are going to be, the virtual routers that are going to be performing BGP for route sharing, and essentially sharing whatever you have from your on-prem locations over your direct connector express route going into your VNet or VPC at the end of the day. And there's a lot of different gateway types depending upon what we're kind of talking about. For AWS, we have a direct connect gateway that normally we might want to land our initial direct connect circuit onto, but then from there connect that out to a lot of virtual gateways that might be deployed inside VPCs, and then that way we kind of have peering with multiple regions from that direct connect. Or we can, like with the Azure method, as far as just peering it direct into the VNet via that virtual gateway. So there's a lot of different ways in which we can kind of do this, and also too totally different peering option with the transit gateway, which we'll get into a little bit more. But the main thing is that this is going to be your method for actually performing BGP and route sharing at the end of the day between your VPC and VNet. So you need to make sure that ultimately you're building a connection from your express route and direct connect to these gateways. And then from there that these gateways are ultimately associated with the VPC or VNet that you are trying to share routes with your on-prem infrastructure. All right, but this isn't the only way in which you can necessarily peer these services. If you are a large, provider, you're consuming, it's like cloud WAN or virtual WAN services from these CSPs, right? This doesn't necessarily mean that you need to terminate your direct connect or express route directly into a VNet or VPC, and that's your only option. You can terminate these usually onto that global WAN service that the cloud provider is offering as well. All right. So like, for example, in the instance of, virtual WAN here with Azure, right, we can build that express route, that circuit, peer it onto a express route gateway that then associates itself with that secure WAN hub that's associated with your virtual WAN. And so from there, we're able to kind of build the connectivity, get it into your WAN backbone, and then that way disseminating the routing information to all of your VNets that are then associated through the virtual WAN rather than it needed to hairpin to a specific VNet to hit those on-prem resources. And once again, this kind of depends on what you're trying to do and what your network design is, but it is another option for how you can kind of handle connectivity at the end of the day and build this out. Right. Cloud WAN, on the other hand, right, is associating this via a direct connect gateway, and then building essentially like building an attachment from your cloud WAN to your direct connect gateway, and then associating that right to whatever you're trying to kind of connect to from there, as far as going into your VPCs and building attachments on that, and getting that associated to your segments on your cloud WAN. So it's, it starts getting a little bit different because these services at the end of the day are definitely very, cloud provider specific. But the key thing is that you're not relegated to necessarily landing it into one VNet or VPC. All right, you can stretch this out and get it onto that global WAN service if needed, if that ends up being more efficient for what you're trying to accomplish. All right, other things that's just kind of worth talking about a little bit is just some vendor specific options and unique elements that are worth kind of including as far as the differentiators here. But there are key things that you kind of need to keep in mind when you're actually building this out. So like, for example, transit gateways can be used for learning essentially your direct connect routes and then having a method to sharing them out to multiple VPCs if you're using transit gateways right now today to share routes amongst your VPCs inside your AWS. So this ends up being another peering option. You see this when you actually create the direct connect, that you will get an option to either do private, public, or transit. So this build option ends up being transit gateway for actually doing the peering options. So this is another way in which you can kind of do this and land it in, rather than necessarily going with the cloud WAN or direct VPC. You have transit gateway. And then the other thing I kind of want to get into a little bit is with Azure. Azure also supports Q&Q, which adds another layer for some people of complexity on top of how we're actually peering with Azure. But the kind of cool thing is that with Q&Q, we can effectively, and for those of you that don't know, Q&Q is you're essentially layering your VLAN tags with a customer tag and then a service provider tag. So service provider tag in this instance might be specifically Megaport and how we are building out that connection going to Azure. But as soon as it hits Azure, that service provider tag gets ripped away, and then you have two customer tags inside there, and one might go to one destination and the other one might go to another destination. And that's how it's kind of built out inside Azure. And what this allows you to do, this allows you to do multiple peerings on one express route. So we can do one peering to Azure's, your private IaaS instance, via one peering. And then we can do another peering to Microsoft services and hit Office 365, Dynamics 365, and any service that's kind of on Azure's, public network via the other peering option, and keeping them separate via those customer tags. So it does create a little bit of complexity because you do have to kind of do a little bit of queuing on your end of the equipment, because you need to tag those individual flows within those customer tags, and then egress it out with the service provider tag that we then match, and then use that to send you to your Azure peering. But it is something that is totally doable, so you don't need to build multiple express routes to do multiple peerings at the end of the day. All right. But finally, we're just going to kind of, digress a little bit here, but just to kind of show, a lot of these services are universal across provider. You're going to run into this, run into these concepts regardless of who we're kind of talking about. The only thing it's probably going to just be more specific is when we start talking about, cloud WAN and virtual WAN. But the big thing is, all of these service providers have some kind of on-ramp service that allows for physical connectivity into their equipment. AWS is Direct Connect, Azure's Express Route, Google Cloud, GCP is Cloud Interconnect, Oracle is Fast Connect. And then from, just building either a hosted provided or provider hosted or a dedicated or direct, all of them offers both of these options, with AWS calling it dedicated connection, Azure calling it Express Route Direct. And then same thing again, dedicated interconnect, fast connect direct. So These options are available as well as provider hosted across the board for all of this, which is usually the standard way to do it. And then from a peering standpoint, right, you have, right, like I said, those private transit and then those public peerings. And then same thing with Microsoft, you have private peering and Microsoft peering, which is Microsoft being its public peering option, right? And then GCP and OCI, right, being more so for just the private peering options that are available today, right? But still, once again, this is kind of important to keep in mind from that AWS Azure standpoint. And then from there, it's just, you still have your routing constructs, your gateways that you still have to mess with. And they're all going to be named different. And they're going to be a little bit unique and different with AWS having its, virtual network gateway, the direct connect gateway, the transit gateway. And then with Azure, you have your VNet gateway. GCP, you have your cloud router, and then you have your dynamic routing gateway for OCI, but it's still the same thing that you have to work around those gateways if you're trying to build a peering, layer 3 peering at the end of the day. And then finally, it's just BGP parameters. Normally, a lot of these providers use their own ASNs. So in the case of Azure, GCP, OCI, you're going to be peering with their ASNs via BGP. Right, but with AWS, if you're peering with your IaaS instance, you can build your own ASN. So, right, we could say our direct connect gateway is, 65,000, and then our, virtual network gateway is 65,001 that we're peering with, and so on and so forth. But if we are peering with the public network, we got to use that public ASN if we are ultimately going to do it, because of course, right, it's the public network. We're using public IP addressing, so we can't get away with a private ASN. All right, but that's pretty much it. If you have any questions, feel free to let me know. But yeah, I hope this was kind of helpful for everyone here that's on the call. And yeah, hope everyone has a great rest of their day.